Review of some sequences and series. First off, starting with sigma or summation notation. All right, we have I equals 1 to n. All right, f of I equals f1 plus f of 2 plus f of 3 plus dot 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 all the way out to f of n minus 1 plus f of n. All right, and what does that mean? What does f sub 1? What does f of 1 mean? Well, that means you're going to have some function or expression here, and it has an I in it, and you're going to take I out, and you're going to replace it with the numbers from 1 to 3 in this case. All right, 4 times 1 plus 5 plus 4 times 2 plus 5, right? And then 4 plus 3 plus 5. And it's not a bad idea to go ahead and just kind of write the terms out with the parentheses empty and then put the 1, 2, and 3 in later. Because that way you can kind of keep track of where you're substituting, okay? Wasn't really an issue here, but sometimes if you have like another 2 in the question, like if this was say 4 times 2 plus 2, and then sometimes you'll screw up, I will, and say 4 times 3 plus 3, all right? So be careful with that. And then it's just really pretty simple from there, okay? 4 times 1 is 4, plus 5 is 9. 4 times 2 is 8, plus 5 is 13. 4 times 3 is 12, plus 5 is 17. And then you add these numbers together, and you get 39. There you go. Okay, express the series in sigma notation. So now, this time I'm given a sum written out and asked to use sigma notation to represent it. So that's going to be sigma, and I'll use I equals, and I don't know, maybe I want to start with 1. I could start with some other number. Okay, if you wanted to, you could start with, I could start with like 5, for example. All right, and then this would be 1 over I. All right, and then look, see that's like 1/5 plus, and then when I go to the next one, it's 1/6, right, and so forth and so on until I get to 1/8. So I can do it from 5 to 8. Another way to write this one, there's infinitely many of these, by the way. Let's say you want to start with 1. I equals 1, and they give you a blank and tell you you have to do that. Now what do you have to do? Well, if I'm starting at 1, I need it to be 4 plus I down here, that's all, okay? And then I will finish with 4. Now, either one of these is okay. You know, I would think I would usually use that one, but that one there is all right. If for some reason you wanted to start at like 5,000, then, well, I guess you could do 1 over 5,005 minus I, okay, and go from there. All right, I think. All right, arithmetic sequence. A common difference. The common difference is the amount you change, you either add or subtract. I'm going to put plus minus for add or subtract to each term. All right, and that is D in all of the formulas. Speaking of formulas, all right, the first formula I have is A sub n is A sub 1 plus R times n minus 1, where, D times n minus 1. That's not an R in there. A sub 1 here, this A sub 1 is the first term in the sequence. The D is the common difference. The n is the number of terms, okay? So how many terms are in the sequence? 3, 5, 7, 23. What you have to recognize here is that is A sub n. That is the last term. So I have 23 equals, my first term is 3, plus my common difference, well, 3 to 5 to 7. I'm going up by 2 each time. So it's 2 times n minus 1. And this is, I'm going to be able to find n, which will tell me the number of terms. So I'm going to have, let's see, 23 equals 3 plus 2n minus 2, which is 2n plus 1. And this is 23. I subtract 1 from both sides. 22 equals 2n. N equals 11. If n doesn't come out to an integer, you screwed up. Okay? It has to be a counting number, actually, not just an integer. It has to be a counting number. Okay? You can't have 4.3 terms. You have to have 4 terms. Okay. What is the 35th term of this sequence? All right, now this one here, I know I'm looking for A sub 35, the 35th term. All right, I'm going to use my first term, which is 438, plus, what's the common difference here? Looks like a -6 to me. And then times, I know minus 35 minus 1. So I'm going to have 438 minus 6 times 34. And 6 times 34. Just change that. Sorry about that. I'll get rid of that. All right. 6 times 34 is 204. So the 35th term, a sub 35 is 438 minus 204. 234. And just kind of make sure your answer makes sense. Make sure, like, if it's decreasing here, that all of a sudden you don't have a number that's bigger, which we don't. And that seems like a reasonable answer to me. Okay, 234. That's arithmetic sequences. All right. The next thing we have are geometric sequences. These are the ones where, you know, it's multiplied each time, and the common ratio is the amount you multiply each term by. And of course, that's to get the next term, to get next term. And that is R. That's R, common ratio. Okay. The nth term of a geometric sequence is a sub n equals a sub 1 times R raised to the n minus 1 power. Okay? All right. So, what is the 20th term of the geometric sequence whose first term is 12 and whose common ratio is negative 2? All right, so I want the 20th term. And the first term is 12. That's a sub 1 right there. First term is a sub 1. And the common ratio is R. So I have a negative 2 raised to the 20 minus 1, or 19th power. So a sub 20 is 12 times negative 2 to the 19th. Okay, so I have negative 2 to the 19th, and then multiply that by 12. When you're doing negative raised to a power, make sure you use parentheses there, okay? If you're raising a negative number to an odd power, it's going to give you a negative. If you're raising it to an even power, it gives you a positive. So that can kind of be your own mental check. Did I do that right? And there we go. There's the 20th term. Negative 6291456. All right, so that's negative 6,291,456. You can see geometric sequences kind of get large quickly, or small quickly, as the case may be. All right, next, arithmetic series. Okay, an arithmetic series is going to be the sum of some numbers. Like we did this with the sigma notation, right? This is the kind of the same thing as sigma notation. This is on your reference sheet. The sum of a finite arithmetic series. This formula is provided for you. At this point, S sub n, that's the sum of the first n terms, okay? And the rest of them you know, and a sub 1 and a sub n. Find the sum of the first 20 terms, so that is S sub 20, of the sequence that begins 5, 8, 11. Okay, so I know that I have 20 terms, and I know a sub 1. Oh, what is the 20th term? See, now I'm going to have to do some aside work here to find that 20th term. A sub 20 equals a sub 1, which is 5, plus the common difference, which is 3, times 20 minus 1. So that is that's 60, 57. 5 plus 57. 20th term is 62. So once I find that 62, I can put it in here. All right, so I have 20 times 67 all over 2. I can reduce that, make that a 10. So S sub 20 is 670. The sum of the first 20 terms is 670. Now here's one that's kind of disguised. It's an arithmetic series, but it doesn't come right out and say it. Auditorium has 21 rows of seats. The first row has 18. Each succeeding row has 2 more seats. So A1 is 18. All right. Each succeeding row has 2 more seats. So the D, the common difference, is 2. You're adding 2 each time. All right. How many seats are in the auditorium altogether? There's 21 rows, so there's n rows. 21 is n. All right. So S sub 21 equals 21 times 18 plus, again, I gotta find out how many seats are in that 21st row. Okay, so to do that, over here to the side, A sub 21 is A1, which is 18 plus 2 times, it's gonna be 20. 21 minus 21 minus 1 is 20, so that's 40. It gives me 68 seats in the last row. All right, so I have 68 there, okay? And then when I add 68 and 18, that comes out to 86. So S sub 21 is 21 times 86 over 2. And again, I can reduce this guy. This one here, this time is 43. And just do 43 times 21. And I'll be home free. 903. Uh-oh. Okay. What did I do wrong? Because 903 is not one of my choices, is it? Okay. A sub 1 times 20. That's 58. That's why. And this is what you should do. Right? It's on the test. You get the 903. Oh, 903 is not there. Don't just pick the closest one. Okay? If your answer's not there, you screwed up. All right? Go back and find out where you screwed up. 2 times 20 is 40 plus 18 is only 58. Okay? See? I'm a moron. That should have been 76. Okay? And then when I do 76, right, and divide that by 2, 76 divided by 2 is let's see, that's 338. I need to do 21 times 38. And hopefully this answer will be there. And if it's not, I'll go back to the drawing board. 798. Okay, there we go. All right, good. Next, geometric series. Geometric series, the sum is given to you, the formula is given to you. We want to find the sum of this sequence right here. Okay, so what I have in this case is I want to find S sub n. I don't even know what n is, right? So I need to find n before I can do anything. So I'll take a sub 1 equal, a sub n equals a sub 1 times r raised to the n minus 1. All right? My a sub 1 is 3. My r is 2. I don't know n minus 1, but I do know a sub n is 1, 5, 7, 2, 8, 6, 4. All right. Then I divide both sides by 3. 1, 5, 7, 2, 8, 6, 4. 1, 5, 7, 2, 8, 6, 4. And I divide that by 3. And I get that value. 5, 2, 4, kind of like 288 equals 2 to the n minus 1. Now, some of you may know what that is as a power of 2. I don't. Right? So I'll just do the logs of both sides. And I'll use my power rule and bring that down in front. So I know n minus 1 needs to equal the log of my answer from before, right, divided by log 2. Log 2. I get 19. So n minus 1 equals 19. I add 1 to both sides. I get n equals 20. Now that I know n is 20, I can proceed. S sub 20 equals 3 times 1 minus 2 to the 20th, all over 1 minus 2. Okay? All right, 2 to the 20th is going to be 2 to the 20th is that number. And I'm going to subtract that from 1, and I get negative 1,048,575. And I multiply that by 3, and I divided that by negative 1. And it is going to give me